There is a certain magic to a glowing light in the darkness. It draws our eyes. It fills us with a sense of wonder. For over a century, one particular glow has defined our city streets and nighttime landscapes. Warm, inviting, vibrant red-orange light. This is the glow of neon. It can seem like a mysterious force painting our world with color and energy. But this captivating light does not come from magic. It comes from a simple, humble gas, an element with a quiet and surprisingly useful life. Before we begin, please consider liking and subscribing to my channel, and leave a comment. Every substance in our universe can be organized. Scientists use a special chart for this. It is called the periodic table of elements. This table is a map of the fundamental building blocks of matter. Here we can find neon. Neon is a chemical element, just like oxygen or iron. It has its own unique identity. Its symbol is Ne. Its atomic number is 10. It tells us every atom of neon has exactly 10 protons in its nucleus. This number defines neon and separates it from all other elements. Neon belongs to a very special family, the noble gases. They sit on the far right of the chart. This group includes helium and argon, stable, unreactive, and remarkably useful. If neon is so special, one might wonder where we can find it. On our planet, neon is remarkably scarce. It is present in the air we breathe, but only in minuscule amounts. Imagine 1 million particles. Only about 18 would be neon. It makes up just a tiny fraction of our atmosphere, far less than nitrogen, far less than oxygen, and far less than argon. Neon doesn't dissolve well in water, and it doesn't get trapped in rocks. It is a shy element that keeps to itself. It stays a free gas, thinly spread throughout the air. It is the ultimate chemical loner. Because it has a perfectly full outer shell of electrons, neon doesn't need to react, share, or steal electrons from anything else. It is considered the least reactive of all the elements, meaning absolutely no stable neon compounds exist in nature. This scarcity makes it a relatively precious resource. To obtain it, we liquefy air and use fractional distillation. It is an energy-intensive process that makes pure neon expensive. But beyond Earth, neon is abundant. It is the 5th most abundant element in the universe, common in stars, forged in their cores and scattered by supernovae. The story of neon's discovery takes us back to London in the year 1898. Two British chemists, Sir William Ramsay and Maurice Travers, believed the air held more secrets than nitrogen, oxygen, and argon. Their method, liquefaction and slow fractional distillation, was ingenious and painstaking. From the last fractions, they identified a heavier gas, krypton. Then they captured the very first gas to boil off, something new and light. They sealed it in a discharge tube and applied high voltage. The tube burst into an intense crimson-red brilliance, unlike anything they'd seen. Inspired, Ramsay's young son suggested neon, from the Greek neos, meaning new. With that flash of red light, neon stepped from curiosity to cultural icon. Its glow became the element's calling card, its dramatic announcement to the world. Now, what is neon used for? The most famous use is lighting. That vivid red-orange glow soon powered neon signs. A glass tube is bent into letters or a design, the air pumped out, neon added, and the tube sealed. Apply high voltage, and neon emits its characteristic light. True neon glows reddish-orange. Other colors need other gases or coatings. Argon and phosphors create pale blues, lavenders, and a full spectrum. Bright greens and deep blues often come from argon plus phosphors. Neon light is used in high-intensity airport runway lighting because it can penetrate thick fog. And neon is key in certain lasers. The helium neon laser was among the first gas lasers, producing a stable, high-purity red beam. From research and barcode scanners to teaching optics to airport runways, it remains a workhorse. And although rare in our atmosphere, the average home contains around 10 liters of neon, mainly found in electronics. Neon lamps safely signal high voltage, and liquid neon serves as an effective cryogen for cooling sensitive instruments, its liquid form being 3 times colder than liquid nitrogen. Neon's importance extends far beyond practical uses. It's a perfect model for understanding atoms and light. Electricity excites neon's electrons to higher levels. Then they fall, releasing photons with precise colors. For neon, many drops land in the red-orange of the spectrum. Every element has unique spectral lines, its atomic fingerprint. Spectroscopy lets us find neon across unfathomable distances. Neon's lines reveal temperature, composition, even age. Forged in massive stars, neon is a messenger from the cosmos. In labs, its stable, distinct lines calibrate instruments with reliability. From classrooms to telescopes, neon's value lies in its simplicity, stability, and beautiful, informative light. One of neon's most important properties is safety. As a noble gas, it's chemically inert and non-poisonous. If a sign breaks, the gas simply dissipates into air that already contains trace neon. If you do breathe it in, it will give your voice a higher pitch like helium does. Neon isn't flammable and won't support combustion. The real risk is high voltage. Power supplies and wiring are carefully insulated and housed. Installation and repair should be left to trained professionals. Tubes are glass, and breaking exposes sharp fragments and electrodes, so signs are kept out of reach. Overall, neon is among the safest elements. Respect the electrics and the glass, and its glow is remarkably safe and reliable. And neon is naturally single. Most everyday gases, like oxygen or nitrogen, bond with themselves to form molecules like O2 or N2. Neon, however, is monatomic, meaning it naturally exists as entirely independent single atoms, very unique in the world of chemistry. Long after discovery, neon found a vibrant life in our culture. By the early 20th century, it signified modernity and progress. Georges Claude commercialized neon, and its use spread worldwide. Bright neon cut through night, beckoning customers and defining streets. Mid-century downtowns became dazzling canyons of light. Hand-bent glass made icons. More than ads, they became landmarks. LEDs rose, some neon faded, yet its unique analog glow sparked a revival in art and design. Neon now evokes nostalgia and feels contemporary, a sculptural light with emotional depth. A simple gas became a complex symbol, lighting our streets and our imagination. As we look to the future, what role will neon play? LEDs dominate for efficiency, yet neon endures where its authentic glow is irreplaceable. Artists and designers keep the craft alive as a specialized art form. In science, neon remains a fixture. Calibration, spectroscopy, helium-neon lasers. Its cryogenic properties may cool quantum computers and advanced detectors. Scarcity and energy costs drive recycling and innovation in air separation to secure supply. From curiosity to icon to tool, neon links the atomic to the astronomic, science to art. A small part of our air, a large part of the cosmos, and a bright part of our nights, its glow continues to light our way. Thank you for watching. Please like and subscribe to help out my channel. See you in the next one.